The title of this project is Depression Detection in Tweets from Urban Cities of Malaysia Using Deep Learning. Before we get further into it, let me introduce myself. My name is Priyasri Indra Kumar, and this is my FYP project done under my supervisor, Dr. K.S. Savita. Let us talk about the background and introduction surrounding this project. It is evident that COVID-19 has impacted Malaysians mentally, and it has been raised the question that the government has established less psychological clinics, and that has been recommended by the World Health Organization. According to research as well, a grand total of 23% have been spending significantly more time using social media, and this has led to them turning to social media apps such as Twitter to voice out and vent as an outlet for whatever they've been going through. So this provides a great opportunity for those who are working in health sectors, especially in the psychological department, to gain insight of what may be happening in the mental state of someone who has reacted to a topic in a certain specific manner. So with that, we move on to the problem statement of this project. How far can we go with deep learning, and how can we implement it into the act of identifying tweets that indicate depressive thoughts? The problem statement for this project has been derived from multiple research statements, such as mental illness is an underdiagnosed but observable in online context, and how can computers can take advantage of data to develop features that represent appropriate and complex interpretation tasks. So the problem statement that was able to be derived is, how do we develop an algorithm that can predict text-based depression symptoms using deep learning and natural language processing? The third part of the project would be to identify its objectives, and the objectives for this project were identified using the SMART approach. The first objective is to identify depressive symptoms from tweets using natural language processing and deep learning in the urban cities of Malaysia from the beginning of the COVID-19 period. The second is to make the system identify words that represent depression and categorize them accordingly. Thirdly, to improve the accuracy of the system in identifying tweets that display depression-related words and the specific location. The scope of this project would be Malaysians who use Twitter, but most importantly, the urban cities, because this is where the most Twitter data has been, Twitter engagement has been collected. So the data set for the project would be based on the urban cities of Malaysia during COVID-19. Literature review. Literature review is using studies to patch the gap and set up a foundation between the mental health illness spike during COVID-19 with the implementation of natural language processing and deep learning on Twitter dataset. As we can see here, mental illness spike was a concerning issue during the COVID-19 period. The effect of pandemic on people's mental health was extremely concerning, and the social isolation, fear of contagion, and loss of family members is compounded by the distress caused by loss of income and often employment. This has led to Twitter having been a valuable resource of news and public media for expression during COVID-19 and COVID-19 pandemic. Therefore, social distancing not only tests the capacity for human cooperation, but also brings various mental health implications such as fear, anxiety, grief, and depression. As it is clearly evident that people that were mentally affected during the COVID-19 period have turned to Twitter or other social media apps as a way of their outlet to let go of whatever they're feeling, to express their feelings. Thus, how do we interpret whatever data that is being put out into the world? So with that, we come into natural language processing in deep learning to identify tweets. Studying popular social media platforms such as Twitter and Reddit holds the key to understanding what concerns patients. This has been said by Duke Hurkitz at 2017. So the enhanced technology in computer and internet has driven scale and quality of data to be improved in various areas, including healthcare sectors. Therefore, using deep learning and natural language processing to identify tweets and further classify them using sentiment analysis could help the process of identifying depressive tweets much easier. One of the most interesting parts of the project is the methodology. So let's move on, shall we? The first step of the methodology is to use data extraction using the Twitter API. In order to get Twitter API, we have to create a developer's account using the Twitter platform. And once the Twitter API has been created and approved, you will get the consumer key, consumer secret, access token secret. These are authentication keys to connect the API. So once that has been done, it is used to extract data based on the location and timestamp as it is shown here. These are the geocode of the urban cities in Malaysia. Once the data has been collected, it is important that we study and understand the data. So here we are plotting the data before pre-processing to better understand the raw data. And this is the graph that was used to view the most used word in the data collected. Another key method in understanding data is to generate a word cloud to better understand what data is being presented before pre-processing it. After that, we move into data preparation. Pre-processing has been done in order to make the raw data into a readable format. And some of the pre-processing tasks that will be done is to remove URLs, remove emails, lowercase all the text, remove punctuation signs, remove stop words, and even lemmatized the text. Once we have done that, we move on to formatting the data. Formatting data is primarily synthetic changes to the data that do not alter its meaning, but may be required by the modeling technique. Reformatting data also involves the process of removing links and emoticons from the dataset. How this is done is using tokenization. Tokenization essentially converts words into tokens, which are then used as an input in the normalization and cleaning processes. Finally, we move on into the results and discussion part of the project. The data is split into 80% for train and 20% for test. This is because it is appropriate to ensure that the training data set has adequate amount of data to learn effective mapping of inputs and outputs. So in order to better understand the algorithm, we are going to be explaining the LSTM, which is a form of advanced RNN that allows information to be preserved. The vanishing gradient problem that RNN has can be dealt through the application of LSTM. LSTM is short for long short-term memory. This layer can be networked and can be achieved through the incorporation of this parameter. Keras and TensorFlow that is already present in the Google Colab provides the essential tools required to build the LSTM model. The model created here for this research is a sequential model which will be passing a list of layer cases to the compiler. It also necessitates the integer coding of each input data so that each word is represented by a distinct integer. Additionally, there's an optimizer here being used known as the Atom. This optimizer configures learning rate for every parameter that it is fed and worked efficiently in theory to compare. Finally, an epoch was used in this project. An epoch is a complete cycle of the training dataset. For this particular model, the epoch is set to 10. The number of epoch decides if the weights of the network are altered. Since the number of times weights are changed is directly correlated to the number of epoch, this method can be used to prevent underfitting and overfitting whilst aiming to achieve optimal boundary. Therefore, in order to evaluate if the number of epoches are correct, training and validation accuracy graph is drawn. As we can see here, the learning curve above shows signs of an overfit learning curve which defines that the training dataset was learned too well, but as well as including the statistical noise in the training dataset. One of the limitations of the project thus far is that the model has been trained for too long, resulting in an overfit learning curve. Now we shall be discussing the accuracy of the project. The accuracy of this project is 94%, which is a rather high accuracy. The precision of this project is at a 0.94, which means low false positive rates might be a factor for it. And the recall rate is 0.96, which is very good because the higher the recall rate, the better it is. Finally, the F1 score is 0.95, which is essentially what makes the project complete, and that is better than the accuracy itself. So this is a good sign that the system is working well. Finally, as we can see here, confusion matrices are drawn in order to have a better sense of visualization of the accuracy. As seen, there is a rather high true positive and negative percentage compared to the false positive and negative percentages. This indicates a high accuracy model. Last but not least, we're finally in the conclusion and future works. The conclusion that could be drawn here is that this model has reached the goal of creating a depressive sentiment knowledge base and an algorithm for analyzing textual data for depression detection. This project has reached all of its objective, and the success of it can be used by the government to understand where to extend their services and psychologies to gain insights. This can be implemented into specifically understanding Malaysians better and providing them the care that they deserve. As for future works, the cities within Malaysia that are analysed can be increased, the languages can be extended to Bahasa Melayu, Bahasa Cina, and Bahasa Tamil even, and a visualization board can be developed in the future. With that, I would like to say thank you for listening to my project.